Hi all, welcome back to Whoops with C++ session 35. In today's session, we'll discuss about shallow copy and the usage of default copy constructor and what is the problem with the default copy constructor and how we can overcome that. Okay, so let's discuss about the default copy constructor provided by the compiler. Okay, so then why it is required copy constructor, what exactly it is. So copy constructor is actually a special type of parameterized constructor, and it is used to copy the contents of source object to target object. You have created one object, and if you want to copy that object to another object, then the copy constructor will come into picture. So by default, compiler will provide copy constructor which will do shallow copy. So by default, we have seen compiler will provide some copy constructor. In previous sessions, we have discussed about zero argument constructor, parameterized constructor. Okay, so zero argument constructor will be provided by the compiler. In the same way, the special type of parameterized constructor, that is copy constructor, will also provided by compiler. Okay, now the compiler provided copy constructor, what it will do is it will do the shallow copy. Then what exactly mean by shallow copy? So shallow copy means whatever contents are there in the source object, that will be bit by bit as it is copied to the target object. So for example, if you have an object 1, and if you are trying to copy the contents to object 2, then whatever contents are present in object 1 blindly copied to object 2, irrespective of what is the contents present in object 1. Okay, so we can see three different scenarios where the copy constructor will be called. So that is first thing is while copying already existed object to newly creating object. So the source object is already created, and you are trying to create a new object. At the same time, you are assigning the already existed object to newly created object. And second one, while passing object by value to the function argument. So for the function arguments, we have seen we can pass the function arguments in three different ways. One is pass by a value, pass by address, and call by reference. So whenever you are going for a uh, pass by value for the object to the function arguments, then also copy constructor will be called. And the third one is while returning the object by value. Even returning also we can do three ways. You can return the address, you can return the value, you can return the reference and of object from the function. Okay, so these are the three scenarios where the copy constructor will be get called. Okay, so now um, let's see one program here for the default shallow copy, what it will do. Okay, just observe this program. I have class C employee, and under public section I have created one pointer attribute int empid, and we have a constructor which is taking default arguments. So default argument means so this constructor will work as a default constructor, means zero argument constructor, as well as a parameterized constructor. So and I have a display function which is going to display the employee ID. So here empid is a pointer, so I am allocating memory for this pointer in the heap segment. So later destructor, I'm deleting the empid. So in the destructor we have seen what is the use of destructor. So if you have not followed the previous session, please go through why destructor is required, what is the use of destructor. Okay, please refer that. Okay, now in main, what I'm doing is I have created one object for C employee E1, and the first condition, while the first condition is E2 C employee E2 equals to E1, we are copying the already existed object, that is E1, to newly creating object E2. So that is C employee E2 equals to E1. Okay, but don't try this one. So if I have something like this, say for example, if you are doing something like E2 equals to E1, this is a different scenario. Okay, we'll discuss that later. Okay, so now just focus on here we are copying the already existed object contents to newly creating objects. That is newly creating object is E2. So here copy constructor will be called. So did we provided any copy constructor here? No, this is a zero argument constructor or parameterized constructor which is taking one argument. Okay. So here whenever we see we call like this, then what compiler will do is it will try to look for the copy constructor, try to look for the constructor which is taking the argument like this, C employee, C employee. So something, so argument type will be something like this. It will look for the constructor which is taking C employee as an argument, but we don't have any constructor here. So what compiler will do is it will provide the default copy constructor and it will do the copying. Okay. Now let's see what will happen here. Okay. So here after that, after copying, what I'm doing, I am trying to modify the emp id. So initially e1 will be 100 and e1 e2 both will be having 100 here after copying. Now what we will do is I am going to modify e2 employee id, that is triple one, from 100 to triple one I am modifying. Now later I am displaying e1 dot display, e2 dot display. So what we are expecting here, e1 should be 100 as it is because I have not modified E1 value, and E2 display, it should display triple one, right? So now let us see what will happen here. So G plus plus, okay, compiled successfully, no compilation issues. Now I am executing it. Can you see here? First inside constructor is correct. Employee ID is equals to 111, employee ID equals to triple one. Inside destructor, after that program got terminated, double free corruption detected. So double free corruption will come only when if you are trying to free already freed memory location. So that time double free corruption error will come, that is an exception. Now the aborted will come. Okay, now the codum file got created for this, so process got terminated abnormally. Okay, now if you see here, employee id, it is printing same for both e1 and e2. For e1 and e2, for both it is printing triple one only, but I have not modified for employee 2, right? I have modified only for employee 2 emp id, not for the employee 1 emp id. But how come it is modifying for employee 1 also? Instead of 100 triple one, it is printing triple one triple one. Why it is happening, and why we are getting double free corruption? Okay, just pause for 2 minutes and observe this program and understand. Okay, so now let's discuss this one, why we are getting triple one triple one for both e1 dot display, for e2 dot display also, and why we are getting double free corruption error. Okay, let's discuss about this one. Okay, so now if you see same program I have taken here. Okay, so now what I'm doing is, so analyze this program step by step. Whenever we say C employee E1, now what we are doing is, here we are dealing with the two different types of memory. One is stack memory and heap segment memory. So whenever we say C employee E1, so now before that just take two memory segments. One is stack memory segment and another one is heap memory segment. Okay, so now whenever I say C employee E1, first step is memory allocation for the object. Okay, so memory will be allocated for the object, so it consists of emp id as a data member. Now whenever a memory, after memory allocation is completed, then immediately constructor will be called. So which constructor will be called? That is zero argument constructor will be called. Okay, because we are not passing any arguments here. Since it is passing zero arguments, so it is the default value, id will be 100. So here it will enter into the constructor emp id equals to new int of id. So what we are doing for this emp id, we are allocating memory in the heap segment. Okay, so now first memory will be allocated in the heap segment, say 0x2000 is the memory address, and what is the value we are sending here to 100, so that 100 will be initialized here. Okay, So this is the heap memory, and this address that is 0x200 2000 will be given to this EMP ID, this pointer. Okay, now this EMP ID is a pointer which is pointing to 0x2000, that is a heap memory which is having the value 100. Okay, now so construction is completed. So C employee E1, that construction is completed. So second thing is C employee E2 equals to E1. So then what will happen as a first step, EMP2 uh, so object will be created. Okay, now when I say E1 equals to E2, what the compiler provided will do, copy constructor will do is shallow copy. So whatever information is present in E1, that entire thing will be as it is, it will be copied to E2. From E1 to E2, it is as it is copied. So EMP ID, now what is the value here? That is 0x2000, the same 0x2000 will be given to this. So since it is a pointer, since it is a pointer, EMP to EMP ID is a pointer, and it is also holding to the same memory location. That is, it is also pointing to same memory location. Okay. Now, now observe this one. Now E1 employee ID, E2 employee ID, both are referring to the same memory location. Both are sharing the same memory location. Now what I am doing, star E2 dot EMP ID means whatever value present for EMP ID, wherever it is pointing, there I have to modify the value to 111. So where is EMP ID is pointing? E2 CMP ID, E2 EMP ID is pointing to 0x2000. Now this value I have to modify to 111. Okay. So now the value is going. So the value is modified now. Okay, 111. So instead of 100, now it is 111. So once it is done, what I'm doing is E1 dot display. So in E1 dot display star EMP ID I'm displaying. So what is the value of E1's employee ID? That is 111. So what is the value of E2 employee's ID? 111. So that is the reason we were getting 111 here for E1 employee ID also, E2 employee ID also. Okay. Now what is happening here is, if you are trying to modify because of shallow copy, both the source and target objects pointer attributes are sharing the same memory location, and if you are doing any modification to any of the objects pointer attribute, okay, then it will reflect to other one also. Even if you do E1 dot EMP ID, then it will affect to E2's employee ID. If you are doing E2 dot employee ID equals to some value, then it will affect to E1's employee ID. So because both objects are sharing the same memory location because of the shallow copy, that is, we can also call it as bit by bit copy, which is done by default copy constructor provided by the compiler. Now after displaying this, what we are doing is return 0, means we are coming out of the scope, main scope. So this which is the object got created later, that is E2 object. So first it is created, even since it is a stack, first come last out. So first E2 object will get destroy now. So whenever E2 object is going to destroy, it will call the destructor. So in destructor, what we are doing, we are checking if EMP ID is not null. So EMP ID is having some value. So then what we are doing is delete EMP ID, and EMP ID equals to null. So when we say delete EMP ID, so what will happen is that EMP ID, it is pointing to this memory location, and that will be freed. After that, the object will be destroyed. Now if you observe here, E1 is an object, still EMP ID is having this 0x2000. It is pointing to a memory location which is freed already. So this is nothing but a dangling pointer here. So E1's employee ID is a dangling pointer now. So because of this, now next what will happen, for E1 object also destructor will be called. Whenever destructor is called, it will check is EMP ID is having the value, what value it is having. Yes, 0x2000, it is not null. So then it will try to delete the memory location 0x2000, but 0x2000 is already deleted. Because of that, double free corruption will happen and program will be abnormally terminated. So this is the problem with the shallow copy. Okay, you can see the output here. Sorry. Yeah. So what is the output? Say we can see inside constructor called only once and employee ID is same for both and two times destructor called. So second time when it is calling destructor, we have got the double free corruption exception and the program got terminated, aborted. Okay. So this is the problem with shallow copy. Okay. So now let's discuss about this. What is the problem with shallow copy? Okay. So a default or compiler provided copy constructor will do shallow copy. In shallow copy, source object contents are blindly copied bit by bit to the target object. That is from E1 whatever is there, that entire thing will be copied to E2. So if it is address, it will be copied. If whatever it is there, it will copy directly. If we have any pointer attributes which are holding heap memory, so correct, so we have an object which is holding an heap memory, right? So this is having an heap memory. This object is having a pointer attribute which is holding the heap memory. If we have any pointer attribute which are holding heap memory, then source object and target object pointer attributes point to the same heap memory location, and modification done for one object will affect to another object. So since emp id is a pointer and which is holding the heap memory, if you are doing modification for e2.emp id, then the same modification is affecting to e1.emp id also, because both are sharing the same memory location. Source object and target objects pointer attributes are sharing the same heap memory location. When one object is going out of scope, then shared heap memory of both source and target object will be freed and released. Other object pointer attributes are dangling pointer. So we have seen when E2 when E2 went for when E2 went for out of scope, then destructor will be called for E2 and the pointer attributes memory will be freed, and so it is pointing to the same memory. For this also it is freed, but still it is pointing to some dangling pointer. The now E1's employee ID is a dangling pointer. Now trying to deallocate this dangling pointer will cause us the abnormal termination of the program. So if we have normal data members, then compiler provided copy constructor will do our work. So if we don't have any pointer attributes, then whatever compiler provided copy constructor is there, that is fine for us. No need to write extra copy constructor. Okay. But whenever we have something like a pointer attributes and it is holding some heap memory location, during that time write our own copy constructor. Okay. So that's the problem with the default or compiler provided copy constructor. So just then how can we resolve this problem? So for that, what we have to do is we have to write our own copy constructor that is called user defined copy constructor, and where we have to do deep copy. We have to avoid shallow copy, that is bit by bit copy. We have to avoid. We have to try to create our own copy constructor where we are doing deep copy. So to avoid shallow copy, user has to provide his own copy constructor by following the same signature of the compiler provided copy constructor, and take the necessary steps to avoid shallow copy and perform deep copy. So what do you mean by deep copy? In shallow copy, both the pointer attributes are sharing same memory location, right? Now what we have to do is we have to make sure that for the target object we are creating another memory location, and there we are copying only the contents, that values we are copying, not the heap memory. The pointer value we should not copy. So those steps we have to take care. So that we will discuss in next session. So just observe the syntax here. This is class name. So public class name, const class name, reference source. So this is the copy constructor syntax, and here you have to provide the deep copy steps. Now one more point here you have to remember. So copy constructor, say to avoid shallow copy, user has to provide his own copy constructor by following the same signature of the compiler provided copy constructor. Means whatever this is the syntax of the compiler provided copy constructor. If you are writing your own copy constructor, then you have to follow the same syntax, then only compiler provided constructor will be copy constructor will be hidden and your copy constructor will be called. Otherwise it will try to call compiler provided copy constructor, and it will treat it as a different copy constructor. If you are modifying the syntax, then it will be treated as a different constructor, not the copy constructor. Okay. So here const class name reference is required. So why they have kept reference here? Why not? This is a call by reference, right? So we have seen three different scenarios copy constructor will be called. One is while copying already existing object contents to newly creating object, and also while passing the object by value to the function arguments. So that time also copy constructor will be called. So to avoid that, we are writing class name reference here. So reference is must here. Okay, to avoid recursive calls to the copy constructor, we are using the reference operator here, no pass by value. Okay. Now so you can try, so but you cannot experience the um, recursive calls, because if you are removing a reference and trying if you are trying writing the construct copy constructor like this class name const class name without reference, then what will happen is you will get a compilation error that is saying that it is not matching with your default copy constructor signature. Okay. So now you will get an ambiguity there. Okay. So now why constant is required? So since it is a source object, if I'm not taking a constant and if I'm taking a reference, if you are doing any modifications here, that will affect to source object also. So source object is only for copying, you are not supposed to modify the source object. That is the reason we are writing constant here. So const class name reference source. So this is the syntax for copy constructor. User defined copy constructor also we have to follow the same signature. Okay. So the points to remember for today's session is: to avoid shallow copy done by default or compiler provided copy constructor, user has to provide his own copy constructor for deep copy. And in the copy constructor, source subject is passed by reference to avoid recursive calls to the copy constructor. So they have followed this to avoid the recursive calls. And since compiler provided copy constructor is taking reference, even you have to write your user defined copy constructor also should take reference as an argument. Okay. Source object is passed as constant to copy constructor to avoid accidental modification to the source object inside the copy constructor. So user defined copy constructor should exactly match to signature of default copy constructor provided by the compiler. So that's about for today, shallow copy. And in next session we will see the deep copy, how to write our own user defined copy constructor. Okay. Thanks for watching.